Alright, I got this little boring head to fit, and if you've never used a boring head and bar before, it always takes 3 Allen wrenches to use it. Let me zoom back in and out so you can see them. It always takes 3 to use it. 1 to tighten up the set screw that holds the bar in the head. 1 to adjust the head, move the boring bar in and out to adjust the diameter or the hole you're boring, and 1 to tighten the slide up so it doesn't move. As you're talking and videoing, you need to make sure you've done that. Now, the problem that I'm going to encounter, or try not to encounter, is that this, I need a bore of 1.5 inches, and I've drilled the hole 1 3/4, so I'll have plenty of room there. But this boring bar is exactly 1.5 inches long. I've got a little rule here that's 1.5 inches long. So when I finish, I'm going to be right down there on it, and I'll probably be able to hear this surface of the shank on the aluminum, and hopefully I won't leave any marks. But the marks will just be, well, they'll be a little more than cosmetic, because this is the head, and that's got to be a nice smooth surface there. I might have to take a pass with an end mill to smooth it up, and therefore, of course, that would shorten the stroke a bit. Let's see where we are and set the DRO. Go down 20 thousandths. There we are. I'm always very cautious with these boring heads. I'm turning this one at, I'm going to turn it at 256 SFM on that at 1/2 inch. That's 1960 RPM if anybody cares. I'll zoom in where you can kind of watch what's going on a little bit. Alright, here we go. Now the first pass I probably won't even touch. What I want to do with the first pass is establish everything's set up right, and then I'll go in 10 thousandths or so and see if I'm touching, or maybe the first pass will touch. We'll see. At 1960 RPM and just a 1/2 inch out, there's boring heads are intrinsically out of balance, but there's no vibration in this mill. It's a pretty heavy mill for a home shop. Okay, I don't feel it touching, I don't hear it touching. Watching my DRO, I'm going to go down 1.5 inches. Not watching the boring bar. We're 1 inch and 1.504, 1.506, and we still didn't touch here, so that makes me happy. So what I'm going to do is go in 10 thousandths. First I'll loosen the slide of the bar up, of the boring bar a bit. And where in the world is the mark on this? I don't think this is a Chinese device. I think it's an Indian. Let's see, it's marked in thousandths, it looks like. Or no. What's it marked here? What? I guess it's marked in 2000s. You know, can't see, so keep a magnifying glass handy. It's marked 1, 2, 3, 4. It's marked in it's marked in thousands. No, it's marked in 2000s. Keep my magnifying glass in a baggie. Keep it clean, more or less. Alright, so loosen it up. I'm going to go in what I'm calculating to be 10 thousandths, or maybe it was 8 thousandths, I don't know. Let's see if it touches. Doesn't seem to touch, but we're going to try it at that point anyway. Yeah, we're touching it. We went down 1.524 inches before I heard it hit. And the finish is nice. And I wasn't even trying for a nice finish. So we'll go in another 10 thousandths before we get serious about this. Crap out of it. This grizzly mill doesn't have a power down feed. I didn't know that was a drawback until I learned a little bit. I bought it in 07. I like it, but I'm going to upgrade to a Bridgeport type mill. Probably a little heavier than the Bridgeport. Let's see what that did for us. I like that finish. That finish is going to work. So I bored it a little bit. Just two very light passes to establish everything was all right. But eventually, you know, we're going to get close to 3/4 of an inch. And but how do you measure it? How do you figure it out? Snap gauges, telescoping hole gauges, I don't know what you like to call them. Heard them called both things. But essentially it's a plunger on a plunger. You see this plunging as I push on it. It's spring loaded. And you stick it in the hole at an angle. You always have to have it over at an angle. And tighten it up so that it won't snap, the plunger won't come back out. And then simply bring it over. I like to try to bring it over as vertically as I can. And then that distance that you see there is, let me see if I can get it closer to the camera. That distance you see there is the diameter of the hole. Now, how do you measure that? Well, you stick it in the mic. And then you read the mic. It's remember, I drilled it 1/2 inch and then lightly touched it twice with this boring bar. I took off, I don't know what the first time, almost nothing, and then took off what I think was about 8/1000ths the second time. All right, so I read this thing at 5.510 0.5107. 0.5107. So it's down to the 10,000. So 7/10,000ths. So I'll leave that there, and we'll continue boring, which is kind of a boring subject. This should be the final pass on the bore. I'm at 0.7413, and I want to go to 0.75, so I've got 87/10,000ths to go. So I set this the dial at about a little over 8.5 We'll see what happens. Now you might ask yourself why I shut the machine off while the boring bar is down in the hole. And I did that because this boring bar and this setup tends to allow the boring bar to chatter on the way out, producing a bad finish. But I heard a horrible screech going down, and so I don't have great hopes for that finish. We'll see. What I do to prevent the boring bar from drawing a line as it springs forth is back it off. So back it off many thousandths there, and then bring it out. There we go. And that horrible sound you heard produced a horrible finish. So we're going to go after this again. I think what I'll do is retard the rake, give myself a little negative rake by turning that bar just a little bit backwards. See if that'll change the chatter situation. And we'll take 3 or 4 thousandths off. The actual 0.750 diameter is not critical because I'm going to turn the piston to fit the diameter anyway. However, if I want to make it too much larger, I won't be able to get head bolts in there. So let's try this again. I'll go back to where we were and give it a few thousandths. If I can hold on to my inches. Was that? That'll do it. That'll be about 3 thousandths. give it a shot. This is bad. Well, that was horrible. The negative rake I gave it produced a horrible finish, so I immediately, well, not immediately enough, but I backed it out after about an eighth of an inch, maybe a little less, and instead gave the bar a little positive rake, and that produced a great finish. The rule about chatter is change something. Change the spindle speed, change the feed, change in my case, I changed the rake, and that worked for me. So, what diameter did we wind up with? Well, this half-inch one will no longer measure it. Let's see what I've got here. So there's a larger one, I think. Nope, same size. I don't have anything to easily measure that. So I don't know what size it is. I will have to be very careful checking often when I turn the piston. I'd say it's let's see, about about 51/64. So we'll work with that.